Math practice for class 9. Today we are going to study representation of data graphically in the topic statistics. It's quite easy and scoring, so please watch the video till the end. Data can be represented graphically in various ways. First type of representation we are going to study is the bar graphs. A bar graph is a pictorial representation of the data in which usually bars of uniform width are drawn with equal spacing between them on one axis, the x-axis, depicting the variable. The values of the variable are shown on the y-axis and the heights of the bars depend on the values of the variable. Now some points to note are all rectangular bars should have equal width and should have equal space between them. Remember, rectangular bars can be drawn horizontally or vertically. Generally, you have a practice of drawing vertically, but they can also be drawn horizontally. The height of the rectangular bar is actually equivalent to the data they represent. Quickly, we'll discuss the steps for drawing a bar graph and then see an example for the same. You have to take a graph paper and give the title of the bar graph. Draw the x-axis and y-axis and label them. Label the horizontal axis, generally it represents the independent variable, and the vertical axis for the dependent variable. Label the names of the variable and give an equal gap or leave equal space between each of them on the x-axis. Give the scale of the graph. Remember, all these things you have to make on the graph paper. Now start making rectangular bars with equal gaps and give height according to the respective values of the variable. Make the required analysis based on the bar graph. Note that while drawing a bar graph, it is very important to mention 4 things. The labels on the axis should be there, the title, the scale, and the name of the axis. Example 1. Given below are the seats won by different political parties in the polling outcome of state assembly elections. Draw a bar graph to represent the polling results. Which political party won the maximum number of seats? Note that now see the data is given over here for A, B, C, D, E and F political parties, and the seats won are also given. Now over here, since you can see that it starts from 10 and the highest value is 75, you can take the scale as 1 unit is equal to 10 seats. That will fit the graph paper properly. This is how the bar graph will look. The political parties on the x-axis, the seats won on the y-axis, the gap is equal, and the width of each bar is also the same. So now from the data and also from the bar graph, it is very clear that the party A has won the maximum number of seats. Second type of representation which you are going to study is the histogram. This is a form of representation like the bar graph, but it is used for continuous class interval. Remember the data which previously we saw, that was discrete. Now suppose if you have continuous type of data, then you have to use histogram. So this is the main difference if it is asked as objective. Histogram is used for continuous class intervals. Since there are no gaps in between consecutive rectangles, the resultant graph appears like a solid figure, and this is called a histogram. It is a graphical representation of a group frequency distribution with continuous classes. Now the steps for this, before that, remember, unlike a bar graph, here the width of the bar can be different. First thing is choose a suitable scale to represent weights on the horizontal axis. Choose a suitable scale to represent the frequency on the vertical axis. Then draw the bars corresponding to each of the given weights using their frequencies. You have to select a class interval with the minimum class size. We will see this in the example. Example 2. A random survey of the number of children of various age groups playing in a park was found as below. Draw a histogram to represent the data. Now look at the data carefully. You can see that the width of the class intervals is different. For example, for the first one it is 2 minus 1, or that is equal to 1. For the second last one it is 15 minus 10, means the width of the interval is 5. Hence the area of the rectangle will be proportional to the frequencies of the histogram. Let us see how to make the histogram. Let us make the frequency distribution table for making the histogram. Now what you do is make this table. First is the classes. Over here it signifies age, then the frequency, then width of the class and length of the rectangle. Now frequency is given to you, width of the class you find out by subtracting the lower limit from the upper limit. Like for the first class it is 2 minus 1, which is 1. For the third class it is 5 minus 3, which is 2. For the second last class it is 15 minus 10, which is 5. Now what you do is select a class interval with the minimum class size. In the above example we know that the minimum class size is 1. Now how do you obtain the length of the rectangle? What you do is frequency upon the width of the class. Correct? Because you have to divide the frequency according to the width. So 5 upon 1 into 1. What is 1 over here? 1 is the minimum class size which we have selected. Like for example, for the third class 3 to 5, frequency is 6 and the width is 2. So 6 upon 2 into 1, which is the minimum class size. This is how you get the length of the rectangle. Why this is done? Because over here, for example, when you take the second last class, which is 10 to 15, the class size is 5. The rectangle is the frequency is 10. So now we have selected the minimum class size as 1. So how will you do it? When the class size is 5, the length is 10. So when the class size is 1, what is the length? 10 upon 5 into 1, which is equal to 2. So basically to get the length of the rectangle, what you need to do is frequency upon the width of the class into that minimum class size which you have selected. Now from the table, when you draw the histogram, this is how you will be getting the histogram. You are seeing over here that the rectangles, all the rectangles can be of different size. Now the third type of representation of data which we are going to study is the frequency polygon. You have already obtained the histogram. Now join the midpoints of the upper side of the adjacent rectangles of the histogram by means of the line segment. So you will be getting some line segments joined together. Now to make a polygon, that means you need to complete the polygon. We assume that there is a class interval with frequency 0, 1 before the first class and 1 after the last class, and their midpoints are also joined. Thus the frequency polygon obtained will be from the histogram and it will be called as a frequency polygon. Now frequency polygon can also be obtained independently without drawing the histogram. For this, what we need to do is we require the midpoints of the class intervals used in the data. These midpoints are generally called class mark. The midpoint of a class is called class mark and it is nothing but the average of the upper limit and lower limit. Means class mark is equal to upper limit plus lower limit by 2. We will see this in the example. Before that, just note that although there exists no class preceding the lowest class and no class succeeding the highest class, addition of two class intervals with 0 frequency enables us to make the area of the frequency polygon same as the area of the histogram. You can try it out. The area of frequency polygon and area of histogram will be the same. If the first class is suppose 0 to 10, then what will you do? Then you find the class preceding the class 0 to 10. How? By extending on the negative side. So we extend the horizontal axis in the negative direction and find the midpoint of the imaginary class interval. What will it be? Minus 10 to 0. The class before 0 to 10 would be minus 10 to 0. Let us take an example to see how to draw the frequency polygon without making the histogram. Remember, you can do it both the ways. By first making the histogram and then joining the midpoints by line segments, or directly making the frequency polygon. The following table gives the distribution of students in two sections according to the marks obtained by them. Represent the marks of the students of both sections on the same graph by two frequency polygons. From the two polygons, compare the performance of the two sections. We first find the midpoint of the class, means the class mark for each class. Like 0 to 10, it is 0 plus 10 by 2, which is 5. 10 to 20, 20 plus 10 by 2 means 30 by 2 or 15. So find the midpoint of each class and we have written the frequency beside it. Remember, when we will draw the polygon, we will add extra classes. 0 to 10, the class previous to that would be minus 10 to 0 and its midpoint would be minus 5. Similarly, class after 40 to 50 will be 50 to 60 and its midpoint will be 55. We have obtained two frequency polygons for section A and section B on the same graph paper. On the x-axis you have the midpoints which are plotted, and on the y-axis the frequency is there. Now from both the polygons it is clear that the students of section A perform better than students of section B, because you see 25 marks, that is the highest which is there, and scored by 17 students. So the performance of class A is better. Now some assignment examples. Please practice them so that you can get an idea of the graphs. First one, 100 surnames were randomly picked up from a local telephone directory, and a frequency distribution of the number of letters in the English alphabet in the surnames was found as below. You have to draw a histogram. Now write the class interval in which the maximum number of surnames lie. Obviously from the data it is clear, it is 6 to 8, and also from the histogram you will get it. Now remember over here, when you are drawing the histogram, all the classes don't have the same class length or width. So the proportion of the number of surnames per 2 letters interval will be calculated. Why? Because over here the minimum class length or the width is 2. Assignment example 2. The runs scored by two teams A and B on the first 60 balls in a cricket match are given below. Represent the data on both the teams on the same graph paper by frequency polygons. Now you can see over here that the class intervals are not continuous. Remember, for histogram, for frequency polygon, you have to make the class intervals continuous. Generally they are given continuous, but if not, like in this case, you just have to add 0.5 to both the class limits. Like for example, it is 1 to 6, 7 to 12. So what will be the first class? It will be 0.5 to 6.5, and the second class will start from 6.5 up to 12.5. So this is how we will make all the classes continuous, and obviously add one class previously and at the end. Now to find the class mark, the same formula, upper limit plus lower limit by 2. So for the first class, which is 0.5 to 6.5, the class mark would be 6.5 plus 5, means 7 by 2 or 3.5. For the second class, which is 6.5 to 12.5, it is 6.5 plus 12.5 by 2, means 19 by 2, or it is 9.5, and so on. So this is how we will make the frequency polygon. So in class 9 statistics topic, you just have the data representation by the form of graphs. Please do like and share the video and subscribe to Math Practice.